In my career, I've designed many 4 to 20 milliamp current loop transmitters, testers, receivers, all sorts of things involved with that, and I'm always interested in the design of these. And for quite a long time, I've been manufacturing small current loop testers, and indeed I did a extended YouTube video on the design of one of them, and showed another one being demonstrated, diving somewhat into the theory of how 4 to 20 milliamp current loops work and how their transmitters and receiver circuits work. And I've been seeing some of these mostly Chinese-made inexpensive testers, and up to this point most of them seemed to not be what I would have wanted to use on a job site. And I found this one just with a random search, just checking to see if anybody had come up with anything like what I really wished I'd had, and this product came up here. This is a brandless thing. Well, the brand is listed as TKXEC. It's another one of those nonsensical, throw a bunch of letters together Chinese quote-unquote brands. But it costs $25.99 on Amazon, and they list it as the adjustable 4 to 20 milliamp signal generator current voltage analog simulator, 0 to 10 volts, 0 to 22 milliamp signal sources for value adjusting PLC controller panel LED testing calibration. However, there's a lot of nonsense in the listing, and so I had to buy one to actually see what it was like. And initially I'm pleased with it. I'm going to do more experimentation with it, but I'm going to go through the Amazon listing here just a little bit for a moment to show some of the objections I had with what they had. So it's listed as battery powered. That's true, but it's also powerable from USB or from an external source connected with the terminals that are on it. It says it's a voltmeter, ammeter. It does not measure anything. This is not a voltmeter or an ammeter. It cannot be used to measure external signals. It's a signal generator. So that's nonsensical. High precision, 0 to 10 volts, 0 to 22 milliamps. Precision is 0.01 volts or 0.01 milliamps. Can be calibrated. Power supply, built-in battery, and then they do say here micro USB 5 volts or external power DC 15 volts to 30 volts. So they do correct what they set up here down a little further. Then they say this current output is 2, 3, 4 wires. Okay. What they mean there is with current transmitters like this device, you can have ones that are designed to be 2-wire devices, 3-wire devices, or 4-wire devices. A 2-wire device is powered from a loop that it's connected to and does not use power of its own. A 3-wire device is powered off of the loop power, but indirectly it's not itself part of the loop as far as getting power, but it uses the same power supply as the loop. It can also mean that you have an external power supply separate from the loop, but it has a common wire with the loop itself. So the power supply and the current loop share an electrical connection. So that's a 3-wire device. 4-wire means the transmitter is independently powered from a separate power source that has no electrical commonality with the 2 wires of the current loop. Passive and active are fully compatible. Well, that's also a little nonsensical. Compatible with what? I think what they mean there is passive would be like a 2-wire device where it is using loop power and acting kind of like a variable resistor. It's not really passive, it's actually very active, but I think in the nomenclature they're using, they're referring to that as passive. And then active, I think, is what they're referring to when they mean powering the loop. Okay, coarse adjustment and fine adjustment dual mode, and that is true. You can set it up to be adjusted with a coarse increment or a fine increment of turning the knob. And you can also adjust the number of circles can be set. I'm not sure what they mean by that. Custom quick adjustment mode, which also is kind of meaningless by itself. Store output value when power off, and that is true. You can set it up so it memorizes the value you were most recently set at, and it will return to that setting when you power it back up. It has output short circuit protection, reverse connection protection, and charging protection. So that would be in relation to the battery, that last part. And then we have to scroll way down to get more information. Package dimensions 4.65 by 3.46 by 2.13 inches, 5.2 ounces. It includes one lithium polymer battery. It's required and it's included. First available date, July of 2021. Manufacturer, Shenzhen something something, all run together, but so some company in Shenzhen, China. Know the place pretty well, lived there for a while. But didn't learn to speak words like that. Okay, let's go on. Now they have some stuff here. Here it lists more of the modes in this amazing, hard to read font. It can go positive and negative with the voltage output. A high-end housing. Well, it is a nice housing. I'm not sure if it's high-end. Short circuit protection, quick adjustment. Quick is subjective. Multiple output ranges can be set. Factory default is 0 to 10 volts for voltage mode, or 0 to 20 milliamps for milliamp mode. A variety of display modes can be set. I don't think that's true. There's just two modes, voltage or current, and the parameter set, but I don't know what they mean by this. Once again, they talk about 2, 3, 4-wire system, passive and active, protections, 3 power modes, external power supply, USB or built-in battery, voltage and current regulation, 1 key switch. I think that means that there's one button to push to change between voltage and current regulation. Once again, they talk about coarse and fine adjustments, custom adjustment. Battery charger includes over current protection, automatic charge management, and a power indicator. Then they say 4 high light digital tube. Huh? Well, it's a 4-digit LED display is what they meant to say. They kind of stumbled over their English words. So anyway, then they have more pictures and stuff, but that's as far as I need to go on it. They do mention, once again, that the output signal has short circuit protection, no longer afraid of wrong wire burning meter. 24 volt input reverse protection, battery charging, current automatic control, full automatic, no flushing. No flushing. Power failure stores the boot output value. Well, that means if you turn the power off and you store the value, it'll come back if you've saved the value and retrieve it. They talk about the powers again. They mention that it's a 1000 milliampere hour 3.7 volt lithium battery, and it says it's optional, but it's included and installed. As long as one can work, can also be connected at the same time. I'm not sure what they mean by that, but I think it means that if you're using the external power source, you can also have it plugged in or running off the battery. Not really sure. They show this thing with the micro USB 5 volts coming in, external 24 volts coming in, power going into the built-in lithium polymer battery, and then really dark and hard to read, CPU processing and display adjustment unit. Okay. Built-in lithium battery version, you can check the battery level using the device itself. Then there's some diagrams showing voltage connection, which terminals to use, current in 2-wire mode, which terminals to use, and how to connect it up in current passive mode. Well, they're just using it they're deriving the power for the unit off of the loop here, which they're doing here anyway. So anyway, that's the end of their description. So let's get to the real device. Okay, here's what comes in the box. The device itself, pretty good looking, seems to be pretty well made. Decent quality plastic housing with dirt on the bottom. It's not a potentiometer, it's a rotary encoder, so it just keeps turning around. And it's acting like a multi-turn potentiometer. Also for setting parameters and things like that, it's also a push button, has a nice feel to it, and it's a metallized plastic knob. Seems pretty good. 4-digit LED display, so much nicer than LCD, especially if you're working in some dark control panel or part of a factory. Kind of hard to read, but still legible nomenclature for the 6-terminal plug, and the plug is unpluggable. If I can get it out with one hand. I don't know if that's a Phoenix type plug. No, this seems to be a more proprietary type. It's certainly not compatible with the standard Phoenix design that a lot of companies make that are compatible with this. But at least it's unpluggable, that's important. There is totally meaningless arrows and pluses and minuses on here. There's a battery indicator, a voltage LED, a current LED telling you which mode it's in. On the bottom is a micro USB connector, and that's for powering the unit and or charging the battery, and they give you a short little cable, USB type A to micro USB, just enough for charging it up from any little USB wall wart or a computer or anything you can plug it into that has a USB plug on it. Power switch, and this is only for the battery. If you're powering it through the terminals up here or powering it from USB, it just comes on whenever those power sources are on. This only turns it on as far as battery power goes. There's also a push button here, nice metallized, I'm sure it's plastic, but metallized button with a nice clicky tactile feel, and that switches the mode between current and voltage mode. And then they put on here it's DC plus or minus 10 volts and 0 to 22 milliamps. Those are the overall maximum ranges that it can do, but it has additional ranges within the limitations of these advertised ranges here on the front panel. So on here we've got the ground, that's the common for pretty much everything. There's actually 2 ground terminals. There's the 24 volts, that's for powering this from 24 volts. And that also means if you're treating this like a 4-wire device, you can have the power being input here from a 24 volt power supply. It actually doesn't need to be 24 volts, it's just what they're putting it here for short. It's a wider range of voltages than that. But 24 volts is a sort of industry standard for 4 to 20 milliamp loop power supplies. So if you're going to call it something for short, that's a good thing to call it. There's the voltage, let's see, the voltage output, analog voltage output, I guess, AV, analog current output. And then there's the analog current plus, and that's something you use for one of the wiring configurations. They also give you a small screwdriver of a size that's appropriate for loosening and tightening the screws on the terminal block. That's a nice touch. Since this does not have any test leads and it just has these compression type screw terminals, they do give you a set of 4 alligator clips with the flexible boots, which you can make your own cords with of whatever length and wire type you may wish to use, and a total of 6 little pin connectors that can be, I guess they're supposed to be, I don't know if you're supposed to solder into those or what. It's not really clear to me. They don't appear to be crimp terminals. I think they're soldering. You're supposed to stick a wire into there and solder it, maybe. I'm not sure. Never seen ones like that before. Alright, I figured it out. I didn't see it at first, but these pins are hollow. And I have a 22 gauge high strand count silicone rubber insulated test lead wire, just a short length of it, stripping it to 1/2 inch approximately, and then carefully twisting the wires. The wire does stick out the end, as you can see. That facilitates soldering it to the pin. So here's just a little demonstration of that. I have the housing lightly clamped in my pan of ice, and I push it in there and it comes out at the end. Because I have it tipped slightly downwards, it doesn't fall back out, and then I can just sweat solder a little bit there and some will wick back inside the hole and hold it securely enough. Alright, here are the test leads I made up for this. These are all 6 inches long. Mostly when I would use one of these, if I was using it, it would be up close to the piece of equipment, so I didn't need to have a big, many feet of cable laying around. And I also used up the other 2 pins with a somewhat longer length, I think closer to 8 inches, and unterminated but stripped and tinned. So I just have the whole set. That way I don't have loose pieces laying around I don't know what to do with. And there are all of these stuck in there. Now, one thing to note, these types of compression terminal blocks are intended for stranded wire, and they don't work all that securely with solid wire. Although, of course, they can be used that way, but it's generally not recommended. And by putting wires, stranded wires, into these pins, it makes them effectively solid wires. So here it's convenient to not have stranded wires fraying and everything by keeping them encapsulated in these pins. And if you're going to be inserting and removing them a lot, it's probably better than having the stranded wires. But really you could achieve the same thing by just stripping the wire, twisting it and tinning it, and then it would work in here just fine. By removing 4 small Phillips head screws from the holes in the corners of the back panel, it lifts off, exposing the inner workings. And there is a lithium polymer battery, 3.7 volts, 1000 milliampere hours, very similar to the kind that would be used in a mobile phone. And it's stuck down with some double-sided foam tape or a pad, and the wires go around and actually do plug into the circuit board there. There don't seem to be any screws holding that together, so maybe it's just the nut for the potential or the rotary encoder. Well, the knob pulls off quite easily, and I'm just going to unscrew that nut and see if the circuit board will come out. And indeed it does come off that easily. And that little button head comes off and reveals a normal micro tactile push button switch underneath. And these are some LEDs of a type I haven't seen before, flattened off like T1s or T1 and a quarter, whatever they're, 1.5 size. And then a multicolored LED for the battery, because that changes green, amber, and red. So we have input conditioning. I think that black device is probably a diode. And there's a filter capacitor. That IC there might well be one of the many 4 to 20 milliamp transmitter ICs, or just transmitter ICs. Of course, we have the LED display module. There's a little inductor there, some capacitors near it. I wouldn't be surprised if that's a little switching power supply to boost up the voltage from the battery, and maybe just provides all regulation. There's what maybe a capacitor tipped over on its side. This thing over here, I wouldn't be surprised if that's a microcontroller. Oh no, this one probably is there. I think that these 1, 2, 3, 4, 5, and then 3 next to it may have something to do with programming the microcontroller. And then whatever these other ICs do. There's another inductor. So it looks like 2 inductors on the board. Actually, I'm not sure if those are all inductors or if there's something else, but they sure look like inductors to me. But that's a lot of them, if that's what they are. Anyway, so that's what's on the circuit board. Alright, let's turn it on. Use the power switch down here. And it's coming up with a nice display. It looks a lot better to the naked eye than it does on the camera. And I'm currently in voltage mode, nice clear indication. The battery's indicating green. It's 90% at least of fully charged. That's the threshold, 90% or better. And the LED below that's for current. If I push the button here, I can change the mode very quickly between the two. If I'm in voltage, I don't remember what range this is in, but I'm expecting that it's probably 0 to 10 volts. That would be the default. So you can see it's in fine adjust mode there. Every time I click the knob to one more detent, it's actually going in 0.02 volt increments. That's programmable. This would be fine adjust mode, and you can adjust for each click of the encoder how much of a change it'll make in the reading. The fine adjust only affects the least significant digit. The coarse adjust affects the digit to the right of the decimal point. You can set it anywhere from 1 to 50. So by default they're both set to 1, but it's here in fine adjust mode. I'll be getting into the details of how to set this up later on, but this is just a quick overview here. I've decided to put a piece of red gel material. This is just a red filter, and it's wafer thin, so it won't cause a problem in the case. Instead of trying to cut a piece exactly the right size, I'm going to try attaching this with super glue and then just using an X-Acto knife to cut along the edges. I think that'll be easier. Okay, there's the gel filter put on there. Just 4 tiny drops of super glue at the corners. and then trimmed with an X-Acto knife around the periphery, using the edge of the plastic as a guide. Yeah, that filter makes a huge difference. The display is so much more legible in various lighting conditions than it was before. So I would definitely recommend that anybody who buys one of these things consider adding a red gel filter to the display. Okay, I have my bench power supply set to 24 volts, and it's connected up to the two wires I put into the 24 volt and ground terminals. I'm going to turn the supply on, and this just demonstrates that you can power the unit without the USB power and without the battery. The battery switch is turned off here, so the battery's not being used. And the battery indicator is not illuminated at all, so it's not even trying to display the battery at this point because the battery's out of the picture. It's physically or electrically disconnected by the power switch here. So that's that. Okay, for testing the voltage output, I just have my meter here, and I'm going to set it up for voltage measuring connection and put it back into DC volts mode. And the voltage positive coming out is on the AVO terminal going to the red lead of my meter, and the minus side of the meter is connecting to the ground terminal. So let's turn this guy on. I can't change the mode to voltage mode until I've turned it on. So I gotta change it to voltage mode. And right now it's defaulting to 9.2 volts. And I've got 9.18. Let's go up to what it thinks is 10 volts. .98. Let's take it down to lots and lots of turns. This is in fine adjust mode, so I'm really changing the least significant digit and then it's just rolling up. Five, 4.985. Let's try it at 1 volt. 0.9995, essentially 1 volt. And 0, and it's actually switched to millivolts here, so it's measuring 1 millivolt when it should be 0 volts. So it's not completely 0 volts, but it's a pretty small amount. So I'm reasonably satisfied with the accuracy on this out of the box. One thing that this is not good for is just casual tweaking around of a voltage or milliamp value. In another video that I've done, you can check it out on YouTube, it's about 4 to 20 milliamp loops and making a doing a design for making a tester, and this is one of the testers that I routinely make. This one here is not a calibrator. It's not supposed to be precision, although it does get limited by internal adjustments to 4 milliamps minimum, 20 milliamps maximum. It just has a simple knob that you can just move the values around with, you know, not precise accuracy, but easy adjustment over the range. Sometimes this is the kind of thing you want, where you just want to say, well, I want to make the motor run a little faster, or I want to have the motorized valve open a little bit more, close a little bit, and you don't care about the exact amount, but you just want to do it quick and easy. Or maybe you're simulating a pressure transmitter, and you're like, okay, I'm at 2 psi, now I want to see what it's like at 5 psi. Here you'd be going like this for a long time to get it there, but you'd be much closer to being dead nuts at the exact value. So two different applications. Okay, the next test is in their active mode, where the tester provides the loop current and nothing else is required in the circuit except for the receiver. So what I have here is the AIO pin, that's on the orange wire, and that's going through a 250 ohm resistor that's simulating a normal loop receiver. And then it's continuing on through my digital multimeter in milliamp mode, and then it's leaving the meter and returning to the ground connection. That's the black wire going to the ground connection there. So the tester is going to be sending 4 to 20 milliamps out the AIO terminal through the loop and then returning to the ground. So let's try powering this up here. I'm going to run it off of batteries for this. And I have to change it to current mode. And it's saying 5 milliamps right now. And it's pretty close. If I can get it without the glare. Yeah. Come on. There we go. This is calibratable. You can dial it in closer. But, so let's see here. I should be able to turn it down to 4. Oh, it's set up to 0 to... Yeah, it won't go below 0 in the current mode. So it's set up as 0 to 20 milliamps. 0 there is 0 here. Again, 4 and 3.97, pretty good. And of course this is only accurate to the least significant digit. It may be 3.98. There's 12 milliamps. And there's 20 milliamps. So I can check this with a different meter and see if it agrees. So this one's saying 19.90 for 20. So this somewhat more accurate meter is showing 19.98, so essentially 20 milliamps. So this is more accurate than this one here. So I'm going to stick with this one for the moment. And I'm going to dial it back down to 12 milliamps. See what it says by comparison. Okay, 19.998, really close. And 3.99, 4 milliamps. So this is pretty accurate, just out of the box, without fudging with it at all. Okay, to test this in 2-wire mode now, I have my 24 volt bench supply set up. The plus comes out and goes into the AI plus terminal. That's this terminal here. That's the white wire. So my power supply plus is coming in to that terminal. And then the current leaves on the AIO terminal. It's right there. That's the orange wire. It's going through my simulated 250 ohm loop receiver, coming out, going through the meter, coming out of the meter, and going back to the minus terminal of the power supply. Now if I'm correct on this, I shouldn't need to turn this on because it should be powered from the loop. So let's see what happens when I turn the power supply on. Nothing. Okay, maybe I need to turn the power on here. Okay, it's in current mode, and I'm getting 5 milliamps out when it says 5 milliamps. If I turn the power supply off to verify that it's getting power from the loop, not from my power supply, not from the internal battery, I'm going to turn the bench power supply off. Oh, that isn't working. It's still, no, that's correct, yes. It's still saying 5 milliamps. That's what it's trying to put out, but because the loop is not powered, it's actually gone to 0 milliamps. So that's working the way I expect. Let me turn the power supply back on, and it goes to there. So yes, this tester is now acting like a 2-wire transmitter. It is not using its own internal power to power the loop, but it is using the internal battery to power its internal circuitry. So it is not powering itself from the loop. In that sense, let's see, is well, yeah, there's a fine point here. If this was really acting like a 2-wire transmitter, it would be powering itself from the loop instead of from its own battery. But that doesn't really matter here. The point is that the loop power is coming from the power supply here, not from the internal battery, as I've just verified. Let's go up to 10. And let's go up to 20. And 20. And as close as we're going to get. So that's how that works. Okay, one more test here. I've tested this out in current mode by having it work as a loop power supply and in its capacity as a current transmitter or current modulator. That's been demonstrated, and I've shown it working with an external loop power supply. So the tester is not providing loop power, although it's still providing its own internal power from the battery, but the loop is powered from my bench power supply. But what if the battery's dead, or you got the version that doesn't have a battery and you need to use it? I've already demonstrated how you can power this unit internally from a bench power supply or another power source, and I still have it rigged up that way. So if I turn the battery switch off, the unit is not powered, and I have the two leads, the 24 volt and the ground, coming out and going to a channel of my bench power supply, which is set to 24 volts. And I have the tester hooked up in the mode that looks like this with the external loop power supply, so that's still in place. I still have my 250 ohm resistor that's standing in for a normal loop receiver. I still have my meter in milliampere mode displaying the loop current. Currently it's 0. The tester is off and the loop is not powered. I'm verifying that both channels of my power supply are set to 24 volts. The right hand one is providing power to the tester, and the left hand one is providing loop power. So what do we get here? Well, let's try turning on the tester itself. Well, the tester is alive, but there is no loop current, or essentially none. So the loop is dead, but the tester itself is working internally and trying to act as a transmitter, but without loop power it can't really do it. This is further indication that this is not a measurement on here. This is the value that the tester's trying to output, but it is not a measurement of the loop current. So what if I turn that off? Is it possible that this would be powered from the loop if I turn the loop on? I'm pretty sure I already know the answer is no, but let's turn the power supply on for the loop, and the tester is dead, but the loop went down to 0 before it was essentially floating, and the meter here was reading a little residual noise pickup because nothing was driving the loop. It was essentially an open circuit. So now that the loop is powered, even though the tester is internally off, the voltage here went down to a nice clean 0 milliamps. So if I turn the other power supply on, so both the loop and the tester are on, now it's saying it's putting out 5 milliamps, and indeed it is. So you can operate this as a 4-wire current transmitter. In other words, a totally separate power supply powering the tester itself, or the transmitter is what it's acting as, and a separate power supply providing power for the loop. So it will function in that regard. The two power supplies are not encroaching on each other's territory, if you will. The one that's powering the tester is only powering the tester. It does not try to go over and power the loop. And the one that's powering the loop does not try to go over and power the tester. So that's a useful thing to know. I put 4 of these little elastomeric rubber feet on the bottom, just so it won't slide around when I'm turning the knob. And they're still minimalistic enough where if I'm trying to handhold it, they don't really get in the way. Alright, I'd like to talk about the manual a little bit. It's not a horrible manual. I've seen much worse. There are parts of it that are written in very lucid, clear English, and other parts of it that just lapse into poor Chinglish. So it wasn't written in a very coordinated way. I would dare say that different people wrote different parts of it, people with different skill sets in English. But still, some effort went into this, and it covers a lot of ground. It doesn't cover quite everything, but it's a credible manual anyway. You can get where you need to go using it after some head scratching in certain areas and probably some just good old empirical experience playing around with the unit. They do have a chart for the power supply, diagrams for the 3 major ways you can connect it up. Doesn't cover every base, but it's the majority of them. Technical specifications, including power requirements from the 3 different power supplies this can use, charging times, charge current, the fact that there is a, for the lithium-ion battery, there is a charge management circuit in here. It's not just, you know, some simple resistor or something. So they claim anyway. They talk about, you know, what is what on here with a little diagram. They describe the operation of the switches, tell you what the battery indicator means, different colors, whether it's flashing or not. Mentions how you can push the mode button for 1 second, and the digital tube, they definitely had a problem with translation there. Instead of digital display, they're using tube. Flashes for 5 seconds to display the battery voltage. So we can demonstrate that here. I've got it turned on, and I'm going to push the button for 1 second. It's the mode button, not this button, just a 1 second push. It's currently reading 4.01 volts. After 5 seconds it goes back to the normal display. Now it's a 3.7 volt lithium battery, so I'm not sure that that's a meaningful or legitimate reading. either they're charging the battery to a higher voltage than it's specified for, or their measurement system is off and it's not really more than 3.7 volts. So I'm not sure which is true, but take that measurement with a grain of salt. Then they get into how to adjust the parameters, and I'm glad they used the word parameter there instead of something else, because that's what this is. It's a parameter-based configuration system, which gives you a lot of flexibility. On the other hand, some of the things that you have to use parameters here for are really awkward, and you wish they'd just given you an extra button or something on the front of it to select some of these things. Going into the parameters is a bit of a hassle. On the other hand, I think that this is designed just from various clues that I've deduced. I think that they're intending it for something that a more experienced person would configure this using the parameters to do one thing and one thing only, and then give it over to a less skilled or knowledgeable person to use maybe on a factory floor or something for testing positioning valves, or testing inputs to analog equipment, 4 to 20 milliamps or voltage inputs, maybe to use as a calibrator, although even though this is a fairly accurate unit, it's not a high precision unit, and I think if you were actually going to be using it to calibrate equipment, you'd want to use something better than this. Still, it could be useful in that way. So their philosophy here is, we're not giving this to a trained engineer who's going to know exactly what all these buttons and switches mean, so we're going to make it impossible for the casual user or less skilled person on a shop floor to use it in just one way, and then the more experienced person's going to have to configure it to that one particular way. So to that end, it's password protected, and they actually do use 2 colors of ink here. They accentuate things in red, which is kind of nice, I guess. Draws your attention to it anyway. And I'll explain how that works here visually. Then there's 2 charts. One of them is for voltage setting parameters. At first I thought these were unrelated to voltage and current, except some of the contents are clearly voltage or current related. But the way that they, instead of having the text look like it's a title for the table, it's just in the paragraph above it, although you can figure that out pretty easily. So this top table is for the voltage mode, and the bottom table is for the current mode. It shows all the parameters, and matters need attention. Please read this manual carefully before wiring. Turn off the power and then connect. And then if you flip it around the other side, it's in Chinese. So that's the entire manual. One thing that they don't make really clear from the way they show it is which of the 2 passwords goes with what. They kind of give you almost enough information, but I had to play with it to make sure I understood which one did what. As something of a public service, I have a companion document to this video, and I'm calling it the TKXEC model QH-VISG2-ED, which again is the supposed brand and model number of this, even though neither of those names appear on it. Voltage and current generator. This is my own user manual based on the original manual and several hours of playing around and experimenting with this and trying to make the most thorough, clear manual that I could, both for my own purposes years from now when I don't remember how to use this, and also to share with other people. This document in PDF form is on my file share website, which I will either put in the description or as a caption on this video. So I have an overview. I talk about that there's 2 different models of this supposedly. one ending in EN, the other ending in ED, but since it doesn't say those numbers on it, you can't tell which one it is. The one that Amazon sells at the time of writing this, and certainly what they were selling when I bought this from Amazon, was the ED version. The ED version is the one that comes with the lithium-ion battery installed. The EN version is the same tester but without the battery installed. So you must power it externally from USB or from a separate power supply of 24 volts or thereabouts. Or you can optionally obtain your own battery, and they do give you the battery specifications, although not a model number. And then you can install one of those batteries in it on your own and essentially turn it from the model EN into the model ED. So I talk about that here. I talk about the purpose of the manual. I describe briefly the general characteristics of the DC voltage output and the DC current output, which is intended for use in a current loop, and what types of equipment might receive these signals, or how you might use this tester in various industrial applications. Then I have a section on connections. I talk about the 6-position terminal on here, what each point of it does, what size of wires are on there, whether it's better to use stranded or solid wire. I talk about the fact that they include the 4 alligator clips and associated boots. Then I show my own little sketch of what I already looked at here earlier in the video, just a version of that. The 3 basic ways of connecting it up for current mode. You don't really need a diagram for the voltage mode, it's self-explanatory. So then I have a paragraph describing diagram A, a paragraph describing diagram B, which is the loop externally powered, whereas A was the loop powered from the tester. And I address briefly what I think are a horrible set of conventions for describing current loops and transmitters, passive or active. Somebody with a poor understanding of how those terms could be used probably came up with that, and I say so here. And then I go on and describe external powering using a 24-volt power supply. And roll over, and then I go to tester power. I have a section on the different ways of powering it and the characteristics of each. So when I'm in the battery mode, I talk about what the LED means in its various colors and states. I talk about, again, how pushing the mode button for 1 second will cause the display of the battery voltage. I talk about powering it from a 5-volt USB power source. I talk about how to power it from the external power supply. And I talk about that when it's in current mode, even if you're connecting up in what seems to be a 2-wire configuration, the tester itself cannot draw its operating power from the loop, therefore it's not a true 2-wire transmitter. So I describe that. I have an overview of the indicators and displays, pretty self-explanatory, but the manual has to be complete. The controls, including the battery switch, the mode push button, the knob when it's turned and the knob when it's pushed, and pushed for different amounts of time. My own version of the technical specifications, both in imperial units and metric, and including some things, quite a few things, which are not in the abbreviated technical specification in the original manual. And I explain that one of the units of measurement that you can set this up for refers to it as 50 Hertz. And what that actually means, it doesn't mean that this unit's suddenly outputting a 50 Hertz signal. It means that, for example, if you're using this in voltage or current mode to drive the analog input of a variable frequency drive, a VFD, and it might be convenient when you're twiddling the knob here to know where in the 0 to 50 hertz frequency range you're adjusting it to. So instead of having the display in volts or in milliamps, you can program it to display in 0 to 50 hertz. Now here's a big failure on their part. They've got all these different modes and ways of setting up the display and everything, and they neglected to put a 0 to 60 hertz display mode on there. I mean, a big part of the world uses 60 hertz, and therefore motors that are VFD operated would expect 60 hertz for full speed, and they've programmed it so it's only usable in that way in places that are using 50 hertz power. So that's kind of a boo on there. I even checked to see if they had actually maybe added another mode that would have been 60 hertz, but they did not, at least in the firmware version that's on this. Another thing on here would have been nice is if you had had a way to display the firmware version. Many things that are like this have that, so you can, you know, where are you? Are you in the earliest version of firmware, or do you have the more deluxe version? Sometimes that'll change how you interpret the user manual. They don't have that on here. Anyway, so I explain that, and then I talk about how to access the menu where all the parameters are at. This is fairly complicated, so I have a whole page just describing how to get into the menu, and then 2 pages of photos showing what the display is doing for each step of verifying the passwords. There's a basic mode and a more advanced mode. And then I have 1 page each for the parameter tables for current mode and voltage mode. This is the voltage mode, this is the current mode. And then finally I have just a page of general notes that didn't fit in other places. Mostly about the parameters, but other things as well. So it's going to be very unwieldy and time-consuming if I actually try to configure and demonstrate every permutation of setting these up, so I'm not going to. Instead, in this video, I'm just going to go through the parameter table as quickly as I can and describe what each parameter does. So if you're in the voltage mode, and for this table to be applicable, you must select the tester to voltage mode before you go in and start messing with the parameters, or you'll be looking at the wrong table. If you're trying to program the table for current, but the tester's in voltage mode, you're going to be inadvertently selecting parameters for the wrong mode, and you can get into all sorts of screwy stuff there. I got myself badly confused when I was fooling with this. I didn't realize that the tester had to be in the associated mode, and finally figured out why it was acting so squirrely. Okay, so parameter F001 is the adjust mode. You can set it to 0, 1, or 2. Again, this is if you're in voltage mode. If you're in 0, that means coarse adjustment. It takes fewer turns of the knob to get to the desired set point. Or in fine mode, you have to turn the knob a lot more to get where you want, but you can adjust it to a finer resolution. Essentially, in the displayed value, which is 2 positions and then a decimal point, then 2 more positions, if you're in coarse mode and you're turning the knob, you're basically adjusting the position just to the right of the decimal point. In other words, the 0 point something is what you're adjusting. If you're in the fine, then you're adjusting the 0.0 something. Of course, it rolls over. You're not just adjusting that one digit, but you know, if you keep turning the least significant position here, it'll roll over and influence the next one, and roll over and influence the next one. But you can see that you might have to turn the knob so that there's 1,000 detent clicks before you could go from one end of the setting to the other. That's quite a lot if you're in fine mode. Coarse mode, there's only maybe 100 clicks. But there's more to it than that. You can adjust it so it goes in different increments of that level of resolution, and I'll talk about that in a moment. There's also a point mode where instead of turning the knob to adjust a specific setting value for the output, you can instead predefine between 2 and 9 presets of output values. And then when you're selecting the adjust mode to point mode, now when you turn the knob just one click, clockwise, counterclockwise, you're jumping from one preset to another. That could be very handy in many situations. Maybe you're testing a VFD and you just want to test it at 0 speed, you want to test it at full speed, you want to test it at 50% speed or something. You could easily set this up so it has a point mode with 3 points and program those to 0 Hertz, 25 Hertz, or 50 Hertz, for example. You could definitely do that. If you're testing maybe a device from a 4 to 20 milliamp loop and it has some alarm points on it that it's looking for on the loop, you could set the point mode to those specific values that would trigger different alarms. So a lot of things you can do with it. The next parameter, F001, is the output span. This is probably the most important parameter. This determines what the range of outputs you can have. Parameter 0 or set point 0 on there would result in a minus 10 volt up through 0 and up to plus 10 volt range. So minus 10 volts to plus 10 volts. If you set the parameter to 1, it's minus 5 to plus 5. If you set it to 2, which is the default, then it's a 0 to 10 volt signal. 3 will get you a 2 to 10 volt. 4 will give you the 0 to 5 volts. 5 will give you 1 to 5 volts. 6 will give you 0 to 3.3 volts. 7 will be 0 to 2.5 volts. 8 will be 0 to 1 volts. And 9 will be minus 10 to 0 volts. Essentially the same thing as if you put it in 0 to 10 volt mode and reverse the two leads. Parameter 3 is the units that you're going to get within that span. You can have it display the real voltage, and real means what it's trying to output, not necessarily what it's really putting out. But if nothing's broken, the two should be the same. But it's not measuring the voltage, it's just putting out what it's trying to put out. That's the default. If you set it to 1, it will instead show you 0 to 100.0% of the span. So that will be different depending on what the span is set up. If you have this set to 50% and you're in the minus 10 to plus 10 span, 50% of that is 0 volts. But if you have it in the 0 to 10 volt span, 50% would be 5 volts, and you can see what I mean by that. So those two are interactive. Then the next two parameters, F4 and F5, are the increment amount for the position that you've selected, either 0 point something or 0.0 something. That's the coarse and fine. So it's just explaining here that you can go from a value of 1 to a value of 50, and every time you click the knob one detent position, clockwise or counterclockwise, you're going to change that resolution point by this amount, whatever you've programmed it to. It defaults to 1 for both of those. Then it's calibration, F6 through F8. It's going from the overall extremes, minus 10 volts, 0 volts, and plus 10 volts. You have a wide range of adjustments you can put in there. I believe it's an iterative process. So you would just have it hooked up to something, an accurate meter, for example, and crank it around until you get, if it's saying you're putting out 2.5 volts or 2.50 volts, because that's the resolution of the display, that you're actually getting that and you could calibrate it plus or minus quite a bit. I have a cautionary note on here to a paragraph that says, keep in mind that the error on this, the specified error, is no greater than 0.05, which means if you have the display and you've turned it to 0. Or say for example 2.2 volts, that you might actually get 2.25 volts, and that would be within the technical specifications of this product. So if you're looking at it and says, oh, my multimeter here that can have 4 digits of resolution to the right of the decimal point, and it doesn't precisely agree with what it says on the tester's display, I have to calibrate it. It may just be that it's within the error specification of the product, and you're not going to benefit that probably by changing these things. You might booger it up. So I have a cautionary note in there that if you are going to mess with those values, you first check to see what the factory values are, write it down somewhere. In case you get really balled up, you could return to those values. And then finally, if you get into point mode, and there's a cautionary note about here, you have to select F001 to a value of 2 to get into point mode, but you also need to set parameter F100 to some value greater than 0. You need to do both to get into point mode. So down here, F100, point mode quantity, how many points you're going to have. If you've selected it to 0, then it's not in point mode, even if you've selected point mode up here. There's no reason to have a point mode of only 1 point, so that's a disallowed option. Then you can go from 2 to 9. So 2, 3, 4, 5, 6, 7, 8, 9. How many points you could have, right? And then you can put in the point mode values in these higher parameters. Now keep in mind that if you put in a value of 2 here, that means you've got 2 points. So even though you might set this to 2 and think, well, that's a single point, no, it's really 2 points. It's 1 and 2. So that's why there are F101 through F109 point mode values. And regardless of how you've set the output span here, when you're selecting the point mode values for each point, it will always be in the overall maximum span. So you will always set a value between minus 10 volts and plus 10 volts. And you'll do that for each of the different points. Alright, let's take a look at the parameter table for the current mode. Very similar to the one for the voltage mode, but there are some differences. For F001, still the adjust mode, and it's still 0 for coarse, 1 for fine, or 2 for point mode. So that's exactly the same as the voltage mode adjustment. F002, the output span is of course different because now it's current. 0 will be a 0 to 20 milliamp output, 1 will be a 4 to 20 milliamp output, and 2 will be a 0 to 22 milliamp output. The default is 0, so it's going to go to 0 to 20 milliamps. I think that's unfortunate. The most common voltage span for voltage operated things in industry is a 0 to 10 volt signal, and that's what it defaults to. And 4 to 20 milliamps is clearly the most common milliamp current loop setting, but they default to 0 to 20 instead. That's a bit of a screw up on their part, I think. Not a big deal. You can program it and it'll remember your settings indefinitely until you change them. Display units, of course, is going to be different. 0 will get you a real current in milliamps. Once again, it's not a measurement, it's just an intent. A value of 1 is 0 to 100%, and 2 is 0 to 50 hertz. Again, not really outputting hertz, just putting something that could be interpreted as being 0 to 50 hertz. And I forgot to mention in here on voltage that there is also beyond the 50 Hertz option, there is one that's 0 to 1500. I have no idea what that's for. I was racking my brain trying to think what would have a 0 to 1500 setting that you want it to be in those units. Can't think of it. Maybe somebody else knows what that is and can put it in the comments. F4 and F5 are the same. That's just the increment and decrement values for coarse and fine respectively. F6 through 8 do the same job as they do on voltage, but of course F6 is referring to the minimum current in a 4 to 20 milliamp arrangement. So it's going with 4 milliamps as the low point, 12 milliamps, that's 50% of 4 to 20 milliamps, and 20 milliamps. And this is another thing that's weird because, okay, you calibrate it as if it's 4 to 20, but you're defaulting the tester to a 0 to 20 milliamp mode. Kind of squirrely. Not well thought out. Point mode is exactly the same. F100 does point mode quantity. F100 through F109. And I have a mistake in my manual here. I'm going to have to fix that. That should be F101 to F109. And that's again your values. Instead of being between minus 10 and plus 10 volts as they were for voltage, you're adjusting this parameter between 0 and 22 milliamps. And then finally, I'll just read through some of these notes. When a parameter is selected and the display shows a parameter number, e.g. F102, click the knob once to display the setting value for that parameter. Then turn the knob as required until the desired value has been selected. Then click the knob again to return to the parameter list. The tester will automatically increment to the next parameter number, but if that's not what you want, you just turn the knob counterclockwise or clockwise to skip backwards or forwards through the parameter list. And the parameter list might be different from the table. For example, if you have selected F1 or 001 to coarse or fine instead of to point mode, and or F100 is set to 0, then point mode is disabled and you won't be able to see parameters F0 or 101 through 109. Those will be disavowed by the software, if you will. There's no point in showing you parameters that are meaningless for the way you've set other things up. So I mention that in here. As previously noted above, you might find that not all parameters listed above are actually accessible on your tester. This will be because some other parameter has been set to a value that makes some other parameter or parameters inapplicable and thus inaccessible. Review the notes in the parameter table, try to determine where the problem is coming from, if indeed it is a problem, and then change the other parameters as might be required to make the desired parameters accessible. When setting values for point mode, the other parameters in regard to coarse and fine are applicable, but as I already mentioned, you will always have to work in minus 10 to plus 10 span if you're in voltage mode, or 0 to 22 milliamps if you're in current mode. I note that sometimes it seems like changes made in the menu are not applicable right away, and you may actually have to leave the menu and come back into the menu to see it ripple through and have an effect on the other parameters. When you are done with editing a manual, you can just wait for 10 seconds and the tester will automatically exit the menu and return to normal operation. Although in reality, a lot of times you're going in and out of the menu and it's kind of a hassle. That 10 seconds seems to take forever when you're just waiting for it. And actually the preferred way, according to the manufacturer, is instead of waiting for the 10 seconds, you want to make sure that you're exiting as quickly as possible, and also make sure the tester has really saved the parameters and updated everything. So you just turn the knob clockwise to index through the parameters to the highest numbered parameter, then turn one detent click further clockwise, and the display will display F end, which is the end of the list. Then you press click the knob once more, and it will save all the parameters, update everything, and exit the menu back to normal operation. I talk once again about coarse and fine, and exactly how the resolution and the increment decrement part of that works in more detail than was in the table themselves. And because I'm using some terminology in these pages that's different from what the manufacturer calls it in their manual, I have a list of places where I deviated. What the manufacturer calls something and what I call it. They call it output mode, I call it output span. They call it display mode, I call it display units. They're calling it add or sub num for knobs pulse. I'm calling it increment decrement. Point mode num, I'm calling point mode quantity. Point output value, I'm calling point mode values. So, I think I've been about as complete as I can with this. And once again, it's available on my FileShare website for anybody who wants to have a better manual than what the manufacturer provides. I have looked on Amazon for many reviews, and there are a fair number of people who thought they had a broken tester or complained that you couldn't adjust certain things that the table in the included manual suggests you should. And I think my manual does a much better job of addressing that. And if these other people had had this manual, they probably could have sorted their issue out. There's no tech support on this. You know, actually, on the Amazon webpage, somebody has put some effort into way down at the bottom of the page. You have to scroll way, way, way down past all the reviews and things, and there's quite a few pieces of information that somebody has added, either the manufacturer or the seller has added. And there's some things in there which are not included in this manual, and I have in fact incorporated all those things into my manual. Okay, I'm going to just show how to get into the menus here, because it's a little tricky to understand just from the written word. I did illustrate it in my manual as best as I'm able to, but sometimes a picture is worth 1,000 words. So I'm going to turn this guy on. And at this point it doesn't matter much whether I'm in voltage or current mode. I'm just showing how to get into the menu. So again, there are two menus here. One of them is focused on the most commonly used settings, and the other one is primarily for the point mode, because there's a lot of additional parameters for that, and you probably don't want to be bothered with them if you're not going to be using point mode. So we're sitting here in the things operating, and I want to get in and change some parameters. If I just want to go into the basic parameter set, I want to change from coarse to fine, or I want to change the span, or I want to change the units, things like that. That's the basic set. The password, they call it a password, and it functions as a password, but it's not a word, is plus, minus, minus, plus. So the way we get into that is we push the button, the knob, for 3 seconds. 1, 2, 3, and it shows F001. That's just a prompt. We're not actually editing that yet. We turn the knob 1 click to the right, and it shows us a blank password. Now turning the knob clockwise will change it to a plus. Turning it counterclockwise will change it to a minus. So it timed out on me. I was talking for 10 seconds. So once again, I'm looking for plus, minus, minus, plus. Turning the knob 1 click right will give me a plus. Turning it 1 click counterclockwise will give me a minus. So 1, 2, 3. Turn the knob once, and now I want plus, and then counterclockwise for minus, counterclockwise again for minus, clockwise for plus. That's supposed to be a plus, by the way. And then you have to push it, and it gets you into parameter 2. Now you can back up and go to parameter 1, but it defaults to parameter 2. And as we know, parameter 1 is the adjust mode. So I'll go back to parameter 1. I'll tap the knob once, and it's showing me it's defaulted to 0. I could turn it up to 1, which would be fine mode. And I can't turn it past that because I haven't set F100 to a value larger than 0. So it's timed out, and it's been left in fine mode, so I have to go back and change that. So 1, 2, 3, one click, plus, minus, minus, plus, click, go back to F1 or F1, tap it, change the value back to 0 for course adjust, push again to save it, and there we go. Now here's something else I want to show you. I just let it time out there so I could get back to normal operation, but I'll get back into it. I'll do my password, and now I can go up to parameter 8, and then that's the last one. Because I'm not in point mode, parameters higher than 8 are locked out to me. And so the next parameter it gives me is Fn. That's the end of the parameters. I just tap that. It takes me immediately back to normal operation and assures that all the parameters have been saved. Now let's look at if I wanted to get into the advanced password. The password for that is plus minus plus minus. So, oh, that's something else I should have mentioned. If you've adjusted to a different setting for voltage or current, and you want to save that so when you power it on the next time it comes back to that, you just tap the button and it does decimal point, decimal point, decimal point, goes back to normal display. That means it saved that 9.3. It's hard to do this one-handed. So I turned it back on, and indeed it came back to 9.3. So I have to push for 3 seconds to get back into the menu prompt. 1, 2, 3. I'm going to turn it right, and now I want to do plus, minus, plus, minus. So plus, minus, plus, minus. And now it takes me up to F100 right away. And this is an important thing here that, at this point it's only giving me that option. In order to get into something besides that, and again, this mode is for the point mode, it's not letting me get beyond F100 because I haven't set F100 to a greater value than 0. So I'm going to tap that, and F100, again, it goes directly to 2 from 0. 0 is point mode disabled, 2 is for more than that, and I go all the way up to a maximum value of 9. If I've turned it to 2, that means I'm in point mode, but I still have to go back to parameter F001 and turn that into point mode too. But now you'll notice that it allows me to go up to F02. F01 is the parameter for the first of 2 points. F102 is for the second of the 2 available points. If I'd set it to 3 test point or points, I would have been able to go up to F103. So once again, I'm going to go back and turn that off. I don't want to be in point mode, so I have to make sure I put in the password for point mode, which is plus, minus, plus, minus. I have to go in here and turn F100 back to 0, and now it doesn't have any other parameter because I've turned point mode off. So I just tap the button once more to return to normal mode. So that's how you get into the menus. That's how you work with the menus. I'm going to go in here and make sure for voltage mode I've selected course. Oops, I should have been 3 seconds. 1, 2, 3. So I'm going to be doing the basic password here, which is plus, minus, minus, plus. And I want to make sure F001 is set to course. It is. And I want to make sure that my increment decrement for course, which is F004, is set to 1, and it is. While I'm doing it, I'm going to go to F05. I'd already incremented as F05. This one is set to 2. I want that to be 1 as well. So when I'm in fine mode, it's only going to be adjusting 1 tick. So that's that. Now I want to get out of the menu, so I just scroll up to F-end. I push it, I'm immediately back to normal operation. I'm going to go to current mode and do the same thing. Oops, once again, 3 seconds. And once again, I'm in the basic thing, so it's going to be plus, minus, minus, plus. I want to make sure I'm set to course mode, and I am. And I want to set, because I'm in current mode, I want to have it set to 4 to 20 milliamps. That's F002, and 4 to 20 milliamps is 1. So I save that. And I want to make sure that F4 is set to 1, it is. And F5 is set to 1, and it is. So all those things are set the way I want them. Oops, but I'm not. I want to make sure that I'm going to displaying real current and real voltage. So F03 is the display mode, and it should be 0, and it is. Okay, good. So I'm going to go up here to end, push it. I'm going to go back into voltage mode and make sure I have the same setting for real voltage. So 1, 2, 3. Turn right, enter my plus, minus, minus, plus password. And I want to go to F3 and make sure that is indeed set to display the real voltage, and it is. Turned all the way up to the maximum parameter, to F-end, push, and I return to normal operation. That is how this thing works. Notice that the LED has finally gone to red. I've been playing with this thing for hours on one charge I gave it when I first got it out of the box, just by plugging it in with the USB cable. And if I'd chosen to hook up the 24 volts up here, I could recharge the batteries from that. But this is probably the way most people will do it, I suppose. Is there anything else I can talk about in this regard? If you're going to power this thing for a long time, not just going out to a piece of equipment and testing it briefly or calibrating it, you're going to have it hooked up for hours, days, whatever, then you need to be powering the tester off of a USB power source, or you need to hook up a 24 volt power source up here to power it. Otherwise, the battery will get you a maximum of 5 hours of operation, probably not that much in the real world. So 5 hours is a lot if you're just going out and doing some testing and calibration, but if you're going to be hooking this up in place of a transmitter for an extended series of tests, for example, that might last for days, you definitely need to use either the USB or the separate power source to power this thing. The battery won't cut it.